Hello, my name is Elvis Pontes. This work is a result of cooperation between the University of São Paulo, Brazil, and l'Université d'Avignon, France. The paper is entitled Gray Model and Polynomial Regression for Identifying Malicious Nodes in Manets. Well, the agenda for this presentation, the presentation follows with the introduction, presenting the context of the approached problem, then the motivation for solving such problem with the adopted methodologies, later the goals of this proposal as well the hypotheses are then introduced. Lastly, I will summarize the results and conclusions, illustrating some possibilities for future works that, in matter of fact, we are already being conducted by our group. Regarding introduction and motivation, for our proposal it is indispensable to recognize the position of the nodes in a manet, having in mind their basic characteristics. They are ad hoc and mobile nodes. Similar to the manets, the vehicular networks and the wireless sensor networks, they also have the same need of identifying the node's position. So, basically, for measuring the node's position inside the manet, two methods can be adopted. One is the range-based and another one would be the range-free. For the range-based, the range-based technique is influenced by the topology of the environment and by some other external factors as interference, weather, distance between nodes. So this technique takes into account quantitative measures such as the angle for the signal to arrive, the signal strength, the elapsed time for the signal to arrive, etc. In the other hand, the range-free, which was the one that we have adopted in our work, it is based on the network density, quantity of the nodes, which algorithm the nodes used for routing, and on the beacon packets. Those packets, important to note that they carry the information about the node's position and takes into account the x, y, and z axis. So, taking into account that introduction, our motivation is that in the manet, as I said, the node's positioning is quite important, and one of the main problems to be faced is the reliability of such position information. For the security point of view, the challenge is to deal with the nodes that have been compromised in a malicious way or regarding the technical issues for the misbehaving. If one node, the sender or the destination, started presenting fake information about positioning, its own position or the neighbor's position, this can reflect in the entire network. Therefore, such positioning problem caused by the malicious and misbehaving nodes is the major motivation of this work. Hypotheses and goals. Some references in our work are about the nodes which were compromised and refer the information sent to the manet. Our hypothesis relies on a proactive approach, as the best scenario is to anticipate the problems the malicious misbehaving nodes can cause with the propagation of fake information. Therefore, we take into account that it's possible to predict the node's position, having in mind the time series of its historic previous positions and considering the variability analysis of such position. Important to note that the malicious misbehaving nodes present a positioning pattern for this time series with higher variability than the normal nodes. This is the first hypothesis for our paper, analyzing the behavior pattern of the node, having in mind the time series with the best positions of the nodes. Thus, we can trace the variability of its future positions in order to determine whether or not the node is sending the fake position information. Uh, well, after those hypotheses, the goal, therefore, is to anticipate the fake position information sent from the malicious misbehaving nodes. For that, we have used the gray theory in the polynomial regression to predict the node's position, and the analysis of the variability was carried out based on the standard deviation. Regarding our proposal, this slide is going to show the settings for our proposal, as well the scenario, how was prepared the simulations. The simulations were performed on a minute by the Network Simulator 2, having 30 nodes, some of them static, some other mobile nodes. The Network Simulator had simulated the CBR traffic during 150 seconds using the AODV protocol. This minute had 4 types of nodes. The static nodes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They will receive the positioning packets from the control nodes. The control nodes are numbered from 10 to 14. 10 to 14 over here. They are going to communicate to talk just to a pair of the static nodes. Then the control node 10 talks just to 0 and 1. The control node 11 talks to node 2 and 3, and so on. The goal for that is to have just a confirmation that the packets were sent to those nodes. After that, we have the nodes with a random pattern of mobility. They will play the multi-hop role. They are numbered from 15 to 19. They are here. Here they are in blue. And they have the mobility pattern according to the MRG32 model. That is a model, a software to a program to create pseudo-random numbers and for the random pattern of mobility. Last but not least, we have some other static nodes also working as multi-hop just for sending packets. They are numbered from 21, those in green, 21 to 29. Well, still in the proposal, as I said, 2 predictive models were employed. The polynomial regression that is here, beta is the estimator. Over here, z is the sample mean of the observations, and n over here is the number of the observation. In our case, related to each of the position of the nodes at time t. We have applied a special case of the polynomial regression with the grade 1, that is for the polynomial, so that is the linear regression. Some multi-steps ahead were considered with 3, 6, and 12 steps ahead. This is known as the horizon of the predictions. For the another predictive model is the gray theory that was employed in our work. Over here, x0 is a non-negative time sequence which in our model denotes the node position, and n over here is the sample size of the data. We have also employed the same settings for the multi-step ahead, that is 3, 6, and 12, so the horizon of prediction were similar for both of the predictive models. For measuring the positioning information, x and y coordinates that were obtained for network simulator, we employed 2 techniques named in this paper as M that is the angular coefficient, and m2, that is the root sum of a square. They are here and here. The angular coefficient for a given point, I'm just give you some few explanation. So as long as a node sends the x and y coordinates, for example over here, um, uh, we will use the angular coefficient of the point 0, 0, that is the origin point indicated by the point A in this slide. And then we can trace the angular coefficient between this point and this point. It's quite simple. Another employ the technique, the root square between the points, the root sum square between the points. We can take the square of the value of the x coordinate, as indicated over here, and then add to the value of the square of the y coordinate, and finally we can take the root of that sum and divide by 2. So this is going to result in the root sum square. Why to use the m and m2? Because using just one of them, some of the variation of the nodes can pass unnoticed. We have also applied the three speed settings for the mobile nodes, which run in a random pattern. We have used 1 meter per second, 2 and 5 meters per second. So during the movement of the node, the trend is the mobile node to get away from the destination node. And other nodes are used as multi-hop for that communication. 99 different intervals for sending the beacon packets were applied, starting from 0.05 seconds, increasing by 0.1 second. Hence, at the beginning of the simulations, the packets are sent in a really fast manner, but at the end of the simulation, it took about 90.85 seconds to arrive to its destination. We have used so over here we have used two estimates to analyze the variability, the amplitude of the standard deviation and the average of the standard deviation. We have poisoned the network with fake beacon packets. We have worked on 5 types of fake coordinate for those nodes. We firstly used the position values 1% greater than the predicted ones, then 2, then 5, 10, and 20% greater from the real ones. Regarding results, they have shown that the increasing of the variability is directly proportional to the increasing of the speed of the nodes, interval of sending packets, and the horizon of the predictions. This means that as we increase the speed, for instance, as we increase the speed of the nodes, the variability increases as well. Here we have the results for the 2 predictive models, and this slide is for the GM, and the following one is about the PR. As we can see, the results are for the speed 3 meters per second and C 6 steps ahead. Both the graphs for the M and M2 are presented, and both of them are showing the results of variability for our models. As we can see, as we increase the speed, increasing the speed, and as we increase the speed, as we increase the horizon of the prediction, and as we increase the interval of sending packets, as a result, we have the increase of variability. As we can see over here, increasing all those variables, we have the variability increases as well. In the following slide, we can see the same thing, but for the polynomial regression. As we increase those variables, the variability is increasing as well. The most interesting result, the nodes that send fake position, malicious and misbehaving ones, they have also shown the same pattern. As we increase the speed, the interval of send packets and the horizon of prediction, the variability increases as well. In this table, we show how the malicious misbehaving nodes have the variability increased if compared to the normal nodes. Initially, for the coordinates 1% greater, from the real ones with the gray model uh, and multi-steps ahead equal to 3. For the estimator amplitude, we are going to have a 226% higher the variability if compared to the normal node. And for the M2, it is 96% higher than the normal node. In other words, it's clear that the malicious nodes has high variability. The remainder of the table shows the same. We had the larger variability for all the nodes. But it's interesting to note that as the horizon of predictions increases, the difference of the variability between the normal nodes, as we can see over here, decreases. In other words, as faster as the node is, or as longer as the interval of sending packet is, or as larger as the predictive horizon is, harder it will be for identifying the malicious misbehaving node. This is a shortcoming of our model, but we think that using high order predictive models, we can have more accurate predictions for long-term, for larger or horizon of predictions, or for faster nodes, or for a larger interval of sending packets. So, as a conclusion, prediction models can be applied to identify the node's position in the minutes by the variability analysis of the time series. The increasing of the variability, taking into account the standard deviation, may indicate the malicious node and or the misbehaving one. And we have analyzed different variables for the variability analysis. As we can see, we have studied the two estimators, we have different speed settings, different multi-steps ahead, and etc. As some other conclusions, it was possible to identify the malicious misbehaving nodes with minor position variations if compared to the normal nodes, and the proposed method can be used together with other localizing techniques. Some future works for the shortcomings of this paper. Power consumption constraints for the nodes when employing our model. The power consumption should be analyzed. The creation of cooperative games is should be a way to do that, using the theory of games for tracing the best parameters for a target energy saving profile to predict the node's position. So it would be possible to measure the balance between the variability and the power consumption. Individual analysis of how the variables influence the variability would be really interesting to be done. And finally, to have more accurate predictions for faster nodes, for longer intervals of sending packets, and for larger horizon of predictions. Uh, it would be interesting to be employed uh, using higher order or hybrid predictive models for the predictions. So that's it. Thank you very much. Obrigado. Merci. If you have any doubts, I'll be available.